Hello. In this video, I'm going to be showing you how to use fraction bars to model adding fractions that have different denominators. So the first concept to look at is, what is a fraction bar? So most people are familiar with the models for fractions that involve pizzas, slices of a circle. And the challenge with that is once you get beyond about quarters or maybe fifths, it's very difficult to tell the difference between the different slices. So if you were comparing a sixth as a slice of a circle to a seventh, it would be difficult to just visually tell the difference between them. Fraction bars are a little better for this because it's easier to see how much of the total has been represented. So what a fraction bar is, very simply, it involves taking a value that is a fraction, like for example 3/4, and looking at the 4 as being the total bar. It's one whole bar. So I would represent that as a little bar of 4, like this. And then the numerator, or that 3 value, is how many of the 4 are counted. And I use this particular way of modeling fractions more often than the pies because of the precision thing that I was mentioning before, but also students are very familiar with seeing this way of representing parts of a whole because they've seen a loading bar when they've been watching Netflix or watching their game loading or something. They've seen that and they understand what that means right away. Even as early as grade 3, students will say, oh, that's 3/4, that's 75%. They already know these numbers because they've been exposed to them in another context. So that's a fraction bar that represents 3/4. If I was representing 4/5, then I would draw a bar that is 5, and the orientation of the bar is not important. So I could draw it vertically, 5 squares in a row. That's my fifths, and then 4 of them are colored. So that's 4/5. So you can think of it like filling a tube or filling a glass, like that. So same idea. Very quickly, students can see where the 5 came from or where that figures into the model, and they can see the 4. They can actually count those. So that's what a fraction bar is. So let's look at how that can be used in addition. So if I was doing, for example, 2/3 plus 1/2, I would start off by making a fraction bar model for the 2/3, and I'm going to orient that one vertically. So thirds, of which 2 of them are colored. I'll keep using the same colors here. And then the 1/2 I'm going to represent with a fraction bar that is oriented horizontally. And the orientation does not change the value at all. Okay, so what I've got shown here is a 2/3 and a 1/2. And if I'm being asked to add them together, I can't do that straight off the bat. I can't just count and say I've got 3 greens, which is a common mistake when adding fractions. I can't say I've got 3 out of 5 colored. Fractions don't work that way. So in order to combine these two proportions, I've got to make the bars or the totals the same. So I'm going to do that by duplicating the 2/3. So I do a carbon copy of itself, like this. So I still have 2/3 of that first shape shaded. And then I'm going to do carbon copy vertically of this other one. So again, copy. So this second model now represents half, and half of it's been shaded. But now the total rectangle that encloses each of those models is the same size. It has the same dimensions as 2×3. So now I can add those together. So at this point, my total is 6. There's 6 in each of my models. And the number that are colored is 7. So that's an improper fraction, as it's sometimes referred to. Doesn't matter. You could picture, in fact, you can show this to students, that those 3 greens, I'm going to redistribute 2 of them into this first shape. So I end up with all of one of those groups of 6 colored. When I redistribute those greens, those 2 go here. And I've got 1 left here that has nowhere else to go. And that is a model for 7/6. We've got 6/6 in this first group, or 1, and we've got 1/6 in that second group. Okay, we're going to do another one. So let's do 4/5 plus 1/3. So first step is to model the 4/5. I'm going to do that with a bar that is 5 long, and I'm going to color 4 of the 5. So this technique came about after doing some review activities with my grade 9 students, actually. And they remembered doing something with fractions, but they couldn't quite remember about the denominator thing. And so, yeah, we came up with this way of doing it. And then the third I'm going to represent horizontally. This is 1/3. 1 out of the 3 have been colored. So the units for each of these fractions don't contain the same number. They don't have the same dimensions. This is a 1/5. This is a 1/3. So I'm going to have to do some duplicating. Carbon copy. So duplicate, duplicate. So now that's a 3/5, and I can do the same thing over here. I'm going to duplicate this one sideways, so it's also a 3/5. So now my unit, you can see here, is a rectangle that measures 3/5. And I've got to do my colors so that they are the same. So I'm still maintaining 4/5 of the first model that's been colored, and I've got 1/3 of the second model that's been colored. It's just been scaled up so that they have the same dimensions. Okay, so now I can add them together. So how many squares have we got total here? I've got if I redistribute, I'm going to have one of those 3/5s full. Completely colored. And out of the second 3/5 rectangle, I will have only 2 left. So in the end, this is 1 and 2 out of 15. Or I could write the improper fraction, which would be 15, 16, 17 out of 15. Okay, another question that right away students, once they've been practicing a little bit, they'll say, what happens if the numerator is bigger? What happens if we have something like 3/2 plus 4/5? So I've got an improper fraction to start with. Not a problem. So my first step in that, 3/2 means that I've got some object that's been divided into groups of 2. So this first group of 2 represents 2 of those 3 out of 2. And then I've got one more. So that's 3 that's been divided into groups of 2. And then the second fraction that we're adding together with this is 4/5. So I'm going to go, here we go, 4/5, and color 4 of them. like that. All right, so I can start to see, as I did here, I'm going to be duplicating, copying this one off to the right, and I'm going to be copying this one down until they have the same dimensions. So if I copy this one 3 more times, then what I've got represented here still shows 4/5 of something being colored. And then this one I'm going to duplicate 1, 5 times. Duplicating, making 4 copies. Like that. And again, so all of these ones, carbon copy, same as above as the one to the left. And then, so proportionally speaking, this first group still shows 3/2. And this second group shows 4/5. And I add them together. So if you look at how much these groups are, these groups contain 10. And we're going to redistribute a few. So we have groups of 10. Let's see, well, this one's almost complete. So I'm going to borrow 2 from this side and complete it. So I've got a whole one here. I can complete the second one by taking 2 away from there. I can complete this one also by taking 2 away from this bottom left. And that leaves just 1 in the bottom left. Because I've taken 2 and 2 to complete. So the result of that is 10, 20, 31 divided into groups of 10. Which is the same as 3 units, 1, 2, 3 complete, plus 1/10 left over.